Hi guys! Today we're going to look at how we can implement ragdoll physics in Unity. First of all, we'll look at how to configure a ragdoll for a character, and then we'll look at how to activate the ragdoll when the character's killed. We'll also look at how we can target specific body parts and have that affect the ragdoll. Okay, let's start by creating a new 3D project in Unity Hub. Next, we'll go to the Unity Asset Store at assetstore.unity.com. We're going to look for a free asset to use for the scene environment. We'll search for Industrial Set V3. We'll add this one to our assets and open it in Unity. We'll download and import the asset into the project. Then we'll navigate to the new asset in the Assets panel. We'll double-click the Map V1 scene to open it. There's no camera currently in this scene, so we'll click the plus button in the hierarchy and add a camera. We'll set the position of the camera to 15 on the x-axis, 1.5 on the y-axis, and -1 on the z-axis. Then we'll set the rotation to 5 on the x-axis, and -130 on the y-axis. Next, we want to add a character to the scene. For this, we'll head over to mixamo.com. This is a free resource that just requires you to create an account to get access to various characters and animations. We'll go to the Characters tab, and we'll select this character called Romero. We'll click Download. We'll select FBX for Unity and then click Download. We'll create a new folder in the Assets folder of the project. We'll call this Models and save the file to this folder. Back in Unity, we'll go to the Models directory in the Assets panel, and then we'll drag the character onto the hierarchy. We'll rename this Zombie. Let's move the zombie so we can get a better view. We'll set the position to 12 on the x-axis, -0.1 on the y-axis, and -3 on the z-axis. We'll also set the rotation to 45 on the y-axis. You'll notice that the textures are missing at the moment. This is because they're embedded in the FBX file. We can extract them by clicking on the model in the Assets panel, then on the Materials tab, and then on Extract Textures. We'll create a Textures folder to extract to. We'll get a pop-up regarding an issue with a normal map, which we can just click on Fix Now to resolve. Next, we're going to look at how to set up a ragdoll for the zombie. We can use the Ragdoll wizard in Unity to help us with this. To open it, we'll go to the main menu and select Game Object, 3D Object, Ragdoll. We need to drag in the correct bones of the zombie, and then this wizard will create all the required physics components for us. We'll expand the zombie character in the hierarchy. Then we'll drag the hip bone into the pelvis slot, left up leg into left hips, left leg into left knee, and left foot into left foot. Then we'll do the same for the right leg. We'll drag the left arm into the left arm slot. And left forearm into left elbow. Then we'll do the same for the right arm. For middle spine, we'll select Spine 1. And we'll drag the head into the head slot. Finally, we'll set the total mass of the character to 70 kilograms and click Create. Let's have a look at what this has done. We'll switch to the scene view and double-click the zombie to zoom in on it. Now we can see that it's created colliders for each part of the character. If we click on the left leg, for example, we can see that we now have a capsule collider, a rigid body, and a character joint. This is everything needed to have the body parts be controlled by the physics system. If we wanted to, we could fine-tune this and make the colliders better fit our model. We'll just leave it as it is for now and press play. The zombie now collapses in a heap when the game starts. The next step is to be able to control when the ragdoll effect is activated. Let's stop the game and look at how to do this. We'll navigate to the root folder in the Assets panel. Then we'll click the plus button and create a new folder. We'll call this Scripts. We'll double-click this new folder. Then we'll click the plus button and add a new script. We'll call this Zombie. We'll drag this script onto the zombie in the hierarchy to assign it. Then we'll double-click the script to open it in the editor. What we want to do is disable the rigid bodies of the ragdoll when the game starts. We'll create a private array field to store all the rigid bodies. Then we'll replace the start method with the awake method. In here, we'll populate the array by getting all the rigid body components from the child objects. Next, we'll create a private method called Disable Ragdoll. In here, we'll loop through all the rigid bodies. We'll then set isKinematic to true on each one. This will stop physics affecting the rigid body. We'll call this method from the awake method. Then we'll create another private method called Enable Ragdoll. We'll loop through the rigid bodies again. This time we'll set isKinematic to false. Now, in the update method, we'll check if the spacebar has been pressed. If it has, we'll enable the ragdoll. Let's save the script and switch back to Unity to try this out. Now, when we press the spacebar, the zombie collapses. Let's stop the game and take this a step further by making the zombie walk towards the camera. We'll head back over to Mixamo and go to the Animation tab. We'll search for Zombie Walk. We'll select this one. Then we'll click Download. We'll select Without Skin to just download the animation without the model. Then we'll click Download. We'll create a new folder in the Assets folder of the project. We'll call this Animations and save the file to this folder. Back in Unity, we're going to switch to using the humanoid animation type. We'll navigate to the Models folder in the Assets panel and select the zombie model. Then we'll select the Rig tab in the inspector and change the animation type to humanoid. We'll click Apply to save the changes. Then we'll go to the Animations folder and select the walking animation we just downloaded. We'll change this to humanoid as well. For the avatar definition, we'll select Copy from Other Avatar and select the avatar that's been created for the model. We'll click Apply to save the changes. If any of this seems unfamiliar, then take a look at our video on animation retargeting, where this is covered in more detail. Next, we'll go to the Animation tab. We'll tick Loop Time and Loop Pose to have the animation loop forever. We're going to use root motion to drive the zombie forwards. We don't want the animation to influence the rotation or the Y position though. To stop this happening, we'll bake these into the pose. We'll also select Original for the Based Upon values to use the original values from the animation. If you want more detail on this, then take a look at our video explaining root motion. We'll click Apply to save these changes. Then we'll expand the animation in the Assets panel and drag the clip onto the zombie in the hierarchy. This has created an animator controller and assigned the walking animation as the start state. In addition to the animation, we'll also add a character controller. This will keep the zombie on the floor and stop it walking through walls. To do this, we'll click Add Component and search for Character Controller. We'll update some of the settings to make the character controller better fit the zombie. We'll set the min move distance to 0, the center Y value to 0.98, the radius to 0.3, and the height to 1.8. Next, we'll go back to the script to have the zombie rotate towards the camera. We only want the zombie to rotate towards the camera when it's walking. To help us do this, we'll set up a basic state machine. We'll create a private enum called Zombie State. In here, we'll add two states, one for walking and one for Ragdoll. Then we'll create a private field for the current state and set it to walking. Next, we'll create a method for the behaviour we want to occur in each state. We'll create one called Walking Behaviour and another called Ragdoll Behaviour. We'll cut and paste the existing logic from the update method into the walking behaviour method. Then in the update method, we'll create a switch statement on the current state. When the state is walking, we'll call the walking behaviour. And when it's Ragdoll, we'll call the Ragdoll behaviour. We're not going to do anything specific in the Ragdoll behaviour in this video, but it will come in useful later down the line. Now let's look at the changes we need to make in the walking behaviour. First of all, we'll change to the Ragdoll state after the Ragdoll has been enabled. Then we want to rotate towards the camera. To do this, we'll add a private field for the camera. We'll make this serializable so that it can be set in the inspector. Then, in the walking behaviour method, we can get the direction from the zombie to the camera. We'll do this by subtracting the zombie position from the camera position. We only care about the XZ direction, so we'll clear the Y component. Then we need to normalise the direction vector to set the magnitude to 1. Next, we need to get the desired destination rotation. We'll store this in a quaternion variable, which is a type specifically for storing rotations. We'll then use the quaternion look rotation method to create a rotation looking in the desired direction. We'll set the forward direction to the desired direction. And we'll set the up direction to the y-axis using vector 3 up. Now we'll change the rotation of the zombie. We'll use the quaternion rotate towards method to rotate from our current rotation towards the desired rotation. We'll have the zombie rotate quite slowly at a rate of 20 degrees per second. We also need to remember to multiply by time.delta time. Let's save the script and switch back to Unity. We'll drag the camera into the camera slot on the inspector. Then we'll press play to try it out. Now the zombie walks towards the camera. But when we press space, nothing happens. That's because the animation is still driving the position of the bones. To fix this, we need to disable the animator when the ragdoll is triggered. Let's stop the game and switch back to the script. We'll create a private field for the animator. We'll also create one for the character controller, as we'll need to turn this off as well. In the awake method, we'll get these two components. Then, in the Enable Ragdoll method, we'll disable both of them. For completeness, we'll also enable them both in the Disable Ragdoll method. Let's save the script and try this out. Now when we press space, the ragdoll is triggered correctly. The final thing we're going to look at is how we can shoot specific body parts of the zombie by targeting them with the mouse. Let's stop the game and navigate to the Scripts folder in the Assets panel. We'll click the plus button and add a new script. We'll call this Shoot. We'll drag this script onto the camera to assign it. Then we'll double-click the script to open it in the editor. What we're going to do is apply a force to the body part under the mouse cursor when the left mouse button's released. Let's start by creating a serializable float field for the maximum force. We're going to have the force vary depending on how long the left mouse button is held down, so we'll create another serializable float field for the time to reach maximum force. We'll also need a private float field to store the time that the mouse button was pressed. To determine what the mouse cursor is pointing at, we'll also need a field for the camera. We'll replace the start method with the awake method. In here, we'll get a reference to the camera component. Then, in the update method, we'll check if the left mouse button is down. If it is, we'll set the time that the mouse button was down. Then we'll check if the left mouse button has been released. If it has, we want to check if any part of the zombie is under the mouse cursor. To do this, we'll create a ray using the camera screen point to ray method, passing in the current mouse position. You can think of a ray as a line that's emitted from a source in a particular direction. In this case, the source is the camera and the direction is determined by the position of the mouse cursor. We can now use the physics raycast method to see if the ray has hit anything. This will check if the ray intersects with anything and also populate the raycast hit object with information about the collision. If there has been a collision, we need to check whether it's with a zombie. We'll try to get the zombie component from the collider that's been hit. We'll check for the component in any of its parent components, as it may be one of the child body parts that we've hit. If the zombie component is not null, then we know we've hit a zombie. If this is the case, then we want to trigger the ragdoll. To allow us to do this, we'll switch to the zombie script and add a new public method called triggerRagdoll. We'll add a vector3 parameter for the force we want to apply to the ragdoll. And we'll add a parameter for the impact point that we want to apply the force to. We'll leave this as an empty method for now and switch back to the shoot script. To determine how much force to apply, we need to work out how long the mouse button was held down for. To do this, we'll subtract the time that the mouse was held down from the total amount of time that has elapsed in the game. We can now use this to calculate the percentage of the maximum force by dividing it by the maximum force time. To determine the force magnitude, we'll use lerp. We'll pass in a minimum value of 1, the maximum force, and the force percentage as the interpolation value. If you'd like more information on how lerp works, then take a look at our dedicated video on this. The next thing we're going to do is calculate the direction for the force. For this, we'll use the direction of the zombie from the camera. To calculate this, we'll subtract the camera position from the zombie position. we're going to modify this direction to give it a value of 1 on the Y direction. This will give some upward direction to the force, lifting the zombie off the ground slightly. Then we'll normalise this vector to ensure the direction has a magnitude of 1. Next, we'll calculate the force by combining the force magnitude and direction. Now we have everything we need to call the new method on the zombie to trigger the ragdoll. We'll pass through the force. We'll also pass through the point the ray hit the zombie. Let's switch over to the zombie script to fill in this method. The first thing we'll do in here is enable the ragdoll. Next, we want to apply the force to the body part that's under the mouse cursor. We can do this by finding the rigid body that's closest to the hit point. To help with this, we're going to add the using statement for link. Link allows us to easily query collections, such as our collection of rigid bodies. We'll order the rigid bodies by the distance from the hit point. Now we have the rigid bodies in order of distance, we can just take the first one. Then we'll add a force to this rigid body using add force at position. We'll supply the force and the hit point. We'll choose the impulse force mode to apply the force instantly. Finally, we'll set the current state to ragdoll. And we'll remove the previous logic we had to trigger the ragdoll. Let's save the script and switch back to Unity. We'll select the camera in the hierarchy. Then we'll set the maximum force to 1000 and the maximum force time to 2 seconds. Let's press play to try this out. Now we can click on the zombie and it will trigger the ragdoll and apply a force to the relevant body part. We can even shoot the zombie while it's on the floor. If we hold the mouse button down, it will apply a greater force. You'll notice that when we do this, the limbs of the zombie get stretched all over the place though. Let's stop the game to fix this. We'll go to the hierarchy and find the character joints. Then we'll tick the Enable Projection checkbox. This will help improve the stability of the ragdoll. We'll do this for all the character joints. Let's try this out. Now it looks much better. The final thing to do is add some more zombies. Let's stop the game to do this. We'll select the zombie in the hierarchy and press Ctrl and D to duplicate it a few times. Then we'll reposition the duplicates around the scene. Let's try this out. Now we have a horde of zombies to shoot. The next evolution of this would be to look at how to have the zombies stand back up again after a period of time. If you'd like to see a video explaining how to do this, then let us know in the comments. If we get enough interest, then we'll definitely cover it in a future video. Okay, that covers everything for this video. A big thank you to all our patrons, we really appreciate you helping to support the channel. If you'd like to help and also get access to the source code, you can find details in the description. Please leave any questions or feedback in the comments and subscribe and click the bell icon so you don't miss the next one. Thanks guys!